Yeah, I think everything is good right now. Hopefully the mic is working well. Gotta continue the project. Alright, so let me refresh real quick. It's been a while since I looked at this. Let me just refresh everything real quick. Alright, so let me see. I don't think we finished the right back stage from last time. I know we finished the memory stage, I'm pretty sure. Yeah, we finished the memory stage. That was for like the loading instructions and save store instructions. We didn't finish right back. So let me just fresh read back on right back. Okay, so there's no bubble, return, setting the instruction, and then this is for types that don't need anything. That don't need any writing, so we just return entirely. Okay? And then these, yeah, so these ones like that. Float. So for, okay, they're using the floating point registers. That's how we distinguish between that. Alright, so what exactly do we need now? Let's see. I guess now we just write. So let's think of what we need. So every integer register, every instruction that uses an integer register is just going to be updating their ALU result into that register. And then floating points, anything that uses floating point register will update to the floating point register from the ALU floating point result. Okay. What else? Load is different. Load is separate. We already have these out of the picture because they don't write, and load is going to be separate because load is using memread instead. I believe. We can check in here. Yes, this memread is specifically for load, so that's using a separate thing. Okay, I guess also, oh yeah, I guess also like floating point register. No, floating point register F0 isn't hardwired to 0, but X0 is. I think we should write that first. Because we're not allowed to write to X0. So you can say like, if it's not float, if not is float, and also, I guess like the destination register that we have usually, since we initialize inst here, we should be able to access it. So inst dot destination register, if that is equal to um, 0, I guess, since it's just the number. So if that is equal to 0, then we should not have that. We'll just return, I believe. So that looks for that. Yeah, we can start now. I'm just gonna add another space here, and let's start with the load. So we need to check our type here. I'm gonna check back in here real quick. Every load just uses load as a identifier. So if inside type equal to load, I need to do instruction type. So if the instruction type is load, in that case, we need to use memread. Or wait, hold up. I think okay. I should write it separately for FPL and that one too. That one also uses Alright, so it's a load. We just need to do write reg, I believe. So using the write reg function, just as we usually do. It's just that we didn't implement it into the. I'm gonna actually reference this real quick. Let me go back up here. Where is it? It's a little more down. Yeah, we're just writing a register, so we already set it up, so we just need to write to it now. Let's see where we are. So writing the register. So we're going to be writing to the destination register, and I guess it's just going to be the mem read of it. So it's going to be mem read, I believe. If that's right, yeah, it's mem read. Let me take a look real quick. Yeah, that's how we access it properly. Okay, I think that should be good. But in the case of it being instance type equal to, if it's floating point load word, I'm just gonna check real quick. FPL. We need to go back. I guess it's up here somewhere. Or no. All like the identifiers are here, so it's gonna be here. Floating point load word is the only one that uses FPL. So, oops. Yeah. Okay. Then we can use that. Let's move back down. Let's move back down here. Okay. So in the case of it being floating point load word. So let's see what we need to do. I'm gonna go back up here for a second. It should be further down. Right here. Okay, so grabbing the memory. Okay, now we're bit casting. Okay, so it's just gonna be. What was the implementation we made down here though? Let me just take a look at this real quick. Well, okay, no, that was just getting the memory for alien results. Okay, I think I got it. Okay, let's see. Did we do anything with that in here? Okay, wait, oh, we do have it in here. Okay, so yeah, we already have the memory in here. So do we not need MCPy? Yeah, I'm just gonna ask Cloud real quick. Or I guess it would just be like, let me just write it real quick. So it's gonna be write to, does it write to integer? Let me see. What are we looking for again? I can find it here. It's gonna be, where is it? Float load word. Did I include that in here? FLW? Oh no, they just had it at the bottom for some reason. Okay, it's a floating point register, so I guess we just write to freg. Yo, what's good, KV, man? I'm doing pretty good, man. How are you? I just finished up exams yesterday. Took an extra day off, and now we're back streaming. Okay, so we still gonna be insta rd, but this one's gonna be. I guess it's still memory. It's just gonna be writing to floating point register instead. I think that's good. Let me check. Let's check. make sure I didn't make any mistakes, or if I'm not thinking about it right. I think this should be right, since we did all like the memory casting over here properly. It should work. Let me see. FB right back has a bug. Memory. Okay, wait. Oh, memory is an integer, so we need a cast, I believe, or no, we just need a memory. Oh yeah. Okay, I messed that up. Memory. Okay. Then everything should be fine. I just made that one little mistake there. Yeah, okay. Let's just do the rest of the cases. Alright, so what else do we need? So integer registers, anything that writes to an integer. So, well, that would be the default case if it doesn't hit anything. So let's do the floating point ones. So if it is a float. So this is true. We can write freg, because that's what we're writing to, and we'll just keep inside our e. And what is it called? Okay. Alright, it's gonna be ALU result. That should be right. And then the final case, which will just be integers. Any random integers, so that'll just be right reg inside RD, and it's just gonna be the same. So it's gonna be ALU. This should be a dot. Alright, okay, I think that's good. Let me think. Semicolon. I think that's good, right? We don't need any further. We don't need any further next cases because this is the final stage. So I think we're done with this. I sure hope so. But let's see. Let's see if we're done. Okay, now I can go back in here and actually write it properly. So we have to write it in reverse declaration, right? So we want to call them in reverse. So right back stage, memory stage, is it not called memory stage? No, it is. What else are we calling? The execute stage. Oh, wait. What are these? Oh, right, we need the memory. Let me see the parameters again. So it's just gonna be taking in mem for each one. How are my exams? Yeah, pretty good, man. Pretty good. Hopefully all A's, but we'll see. Apparently, we use like this system called Canvas for like our grades and stuff. Apparently got hacked. So we're kind of just waiting on seeing what's going on with that. It's apparently like a nationwide incident. Audio quality seems off. Let me check. Give me a second. Maybe it's reading the wrong mic. Is it better now?
I think it was reading the wrong mic. I should probably check that every time I stream. Yeah. Yeah, sorry about that. Alright. Yeah, but my exams are good. Hopefully all A's. And apparently Canvas got hacked, our system that we use for grades, so we're just seeing what's going on with that. Alright, decode, I believe, right? Decode? No. There's one more I forgot in between it. Can't believe I forgot the name of that. Let me go check again. Fetch. Yeah, fetch. Is Canvas thing used by a lot of unis? Yeah, it's like a nationwide incident because a lot of colleges use Canvas. Apparently some people hacked it and now they're asking for money from each college. It's weird, but we'll see how that goes. Apparently some people were doing their exams too, like while the incident happened, so we'll see. We'll see what's gonna happen with that. Yeah, it's crazy. Okay, so alright, so we have all the functions in. Commit pipeline registers. Oh, right, that's just setting the value. Okay, I'm just gonna copy this. And then now we know we don't need this anymore. Don't need that anymore. Okay, yeah, everything seems to be good. I'm gonna just save. I'm looking at commit this real quick. Finished simple pipelining for all stages. I'll commit that and push that real quick. Alright. Alright, that seems to be good. Alright, so now we need a forwarding engine, so that's for any hazard, so there's a couple of hazards that can happen if we're using old memory or if we're using any outdated values or if any two registers are trying to be accessed. Any register is trying to be accessed by two separate memory instructions, it'll cause a collision there, so we have to make sure we space it out properly. So we need to implement two solutions, forwarding and stalling. So let's start with forwarding first. Let me just read up on forwarding again. Forward the result directly from where it is computed to where it is needed. Daily input. Okay, so we need to, we need to add multiplexers. So, okay, if we're taking from destination register, RS1 or RS2, and we need to forward from that. Okay, and it's the same for any other one. So if you have a memory hazard, we'll be taking from the memory stage and moving that forward. And an exception would be, okay, we're never gonna forward x0. It's hardwired to 0, that's fine. Okay, yeah, I guess. Alright, let's think. So the forwarding unit would be happening within the execute stage. So we're taking the values that we get from memory right back. Or the execute memory. Let me just talk with Claude for a second. So I'm going to implement let me see if it's a good idea before I start writing. The plan forwarding needs to happen before the switch. Yeah, okay, so okay, I got the idea of it. All right. Okay, right, we can delete our old switch statement that we had. If I ever need it again, I have it committed anyways to GitHub, so let me just make sure I'm getting the right one. We can delete this whole thing. Okay, from here, we can delete this whole thing. We don't need this anymore at all. This was just for reference so I can look at it again. But we don't need it anymore since we finished that. So get rid of all those. Alright, right here. At the fetch stage, so we need to delete it. Alright, yeah. So now everything looks pretty good. And we have each stage separated, but now within the execute stage, we need to actually change it before the switch statement. So right here, we need to add the forwarding engine. Okay, I think I'll add like a comment here so they know, people know if they look at it. We'll just call this one here forwarding engine. And then here, I'll say execute, so they know how to distinguish properly. Execute switch. Okay. Alright, so what do we need? Let me think for a second. Well, how would we know that it's using RS1 or RS2 exactly? I'm thinking to add maybe some helper functions just somewhere. Maybe that might be a good idea to add some functions so we know when to use RS1 and RS2 to actually do it properly. Okay, let me ask Claude. I'm planning on using some helper functions for this, like functions like uses RS1 uses RS2 and so on. Good idea. Just want to see if it's a good idea. If it is, then I'll probably start getting that. Next, forward conditions, readable and usable, reusable. If you ask Claude something, it basically uses the code. Yeah, I try to tell it not to, but sometimes after a while it goes back to, I'll remind it not to do that again. But the main thing I use it for is just to like get ideas. But yeah, if that's a good idea, then I guess we can. Okay. Do you think we should put it in? Should we put it up here? Like right above our execute? Or should we put it in the header file? Well, I guess it'd be better in here. Okay, so we need certain like functions to use. So we already know we can use the source registers. We need the destination register. We also need to know if it's even writing to a register. So like, these ones. These ones don't write to a register at all, so we need to also get that in there. What else exactly? I'm just gonna reference here real quick. Right, there are some that use rs3 as well, so I guess we can add a rs3 helper function as well. Anything else we need? Let me just go through here and just check. Okay, we can do like this same thing we did down there and distinguish between floats as well. And I guess we'd be taking the type. I messed up. Instruction type, yeah. Instruction type. And also the name of it. So that would be instruction name. Yo, what's up, Ghost? How you doing, bro? We're writing the forwarding engine right now for the pipelining for my CPU emulator. Okay, so everything writes to the register except those couple, which we can go down here and take a look. Yeah, I guess just this. We can reuse this part. It's the same. It's like the exact same. Doing pretty good, man. Just finished exams yesterday. We're back on grinding this project. Alright, yeah, so if this is the case... Okay, what's going on? Alright, there we go. Okay, if that's the case, return false because they don't write to register, and then I guess we don't really need an else case. If it just drops down to that, we just return true. Oh, what's going on here? Wait. I will learn Rust at some point, Ghost, but it's not right now. We haven't declared the instruction. So, Oh yeah, okay. That's gonna be declaring the parameter, so we can just change it to these. This is when we instantiate the parameters, so we'll take it anyways. Yeah, definitely not. I'm not gonna throw away everything, yeah. Hey, but at some point though, we might write some stuff in Rust. It's just like C++ is like the main language used in like workplaces right now. Rust is like really good, but it's gonna be a bit slower to adopt for a couple years, I believe. It's just that so much is written in C++. Yeah, I think this is good. What is risc-v? It's a type of CPU architecture. Just like how you have like ARM, x86, MIPS. It's just a different type of architecture. Different instruction set and everything. It's relatively new compared to x86 and all the other ones, but it's starting to get more adopted into places. Yeah, something akin to x86, yeah, that's right. Okay, so other helper functions. Well, we don't need name anymore. Here, we can take off name. I heard Windows and Linux are going to Rust. Are they? Are they really? Haven't heard about that yet. Same thing here. So we can go by type here too. Okay, using RS1, so does everything use RS1? What doesn't use RS1? Okay, it's gonna be a long time. It's gonna be a long time going through all these. I'm gonna ask Claude. What instructions don't use RS1? And whatever he says here, I'll check. I'll make sure to double check. What instructions don't use RS1? What instructions don't use RS2? And yeah, I just need to know these two. And then I can double check in the documentation. Rust is a faster language and is very safe and not too hard. Yeah, I believe so. Is it faster? I didn't know if it's faster. I thought they're like relatively similar. And I know it's safer for sure. I will learn it at some point. Once it starts getting adopted more into businesses, it's just that so many like places, all their legacy code's written in C++, so they will switch maybe at some point, but it's gonna be a long time. Not a long time, but just like a considerable amount of time. Okay, let's see what Cloud said. Instructions that don't use RS1. Let me double check. You're right for that. JAL doesn't also use it. Yeah, these don't obviously. AYPC. Yeah, okay, so it's just those. Okay. Alright, yeah, if it's just those, we can return those. So by type, I believe those are U types, so those are U type. environment, and also J. Okay. So if our instruction type, so if it's instruction type U, and then also J, or not and, it's gonna be or. J or environment. I mean, C++ is like 0.5 times slower for compiling, but at the end of the day, make your own coding language. You know, C++, just learn how to use LLVM libraries, and you can make a language as fast as Rust. Yeah, definitely. After this project, I'm gonna do a compiler project, probably. Get into compilers, hopefully. And using this emulator to also write that compiler. Okay, if that's the case, return type. Or wait, hold on. Missing something here. Return true, sorry. What's going on here? Compilers are fun? Yeah, I hope so. Yeah, they're not bool, so... I guess we can say... Oh yeah, it has to be not equal to, not equal to. If they're not equal to, then we return... Yeah, then we return true, okay. Okay, I think I got it right. Let's check. Let's write one for rs2 as well. Okay, let's see what doesn't use rs2. Instructions that don't use rs2, all the I types, shifts, loads, all the other ones from before, all M extension. Alright, he changed his mind here. All M instructions use 2 registers. Let me check. Yeah. Looks like they all do use rs2. Yeah, okay, so Claude was starting off wrong, but then he changed it. Okay. Floating point with one source. So that would be floating point square root, and the move ones. Should I check all these? Should I double check all these? Well, let's just think. These ones use rs1 and immediate value, so yeah, that's true. This one's also do the same thing as those, so that's true. Yes, load byte only takes value and then loads it into the register, so that's true. These we already know. Yeah, we saw those. These ones, yeah, I believe so, but I can just double check those. Yes, and also the move ones. Yeah, that looks to be right. Since there's more that don't use it, I guess I'll just check these. Or wait, it's gonna be a lot of checking. Okay, well, I guess it's not a problem. We need this function anyways. Alright, so if this R, then after this one, I think we can, after this one and a couple more, we can write the forwarding engine. Alright, let's just go through this quick. So it's that, V type instructions, store, so S type instructions. What else? Any of these ones, so I believe it's FPA. Oh, right. We need type equals for each one. Alright, that should be good now. What else? Well, we already have U. Or, no, we didn't. Oh, right, okay. Let me just reference here. This one doesn't. This one, I believe it doesn't as well. This one does. Yeah, this one uses 3 actually. That's why we use multiple. So that one will be implemented as well. FPR4. What else? I believe there's a couple more. What did I do? I believe there's a couple more. Epiconv int. No, these ones don't. This one does. This compares RS1 and RS2, so that's true. Yeah, I think that's it. Oh, I guess also fcomp, not fpcomp. Fcomp. I guess also FPS as well. I think that covers all of them. We're anyways gonna get this functions checked by Claude after, so if I miss anything, Claude will catch it. But if that's the case, then we return true. Alright, yeah. We also need one for uses RS3. There's only a couple instructions that use RS3, so that shouldn't be too bad. I believe the only one that uses RS3 are these ones, the R4 ones. Let me check. That should be these ones only. Yeah, I think those are the only ones that use RS3. So we can have that in here. Okay. I guess it's a good idea to also check it uses float. Uses float reg. And we can call that. Oh my god, I can't type today. Oh god, dude. Holy shit. Alright, okay. And that's going to be all our floating point instructions. So I guess I had that somewhere here. I had that somewhere else down here, so we can just copy that. Where did I have that? Oh, this one, yeah. These are all the ones that use floating point registers. And we want to change that all to type, just a regular type. Alright, yeah. I think that's good. It's 2 register. I think all these are good. Oh yeah, for the not conditions, it should be and. I believe, right? Because if one of these executes, then yeah, that's bad. So it has to be and for these ones. The rest can stay or though. Missing return for the false case. Did we? Oh yeah, okay. I guess we do need return false for every single one. If it ever does fall through, just to make sure. For all of these. Any other problems? Uses rs1 missing jalr. Jalr uses rs1 as the base address. Jalr is a separate one, right? Okay. Let me just double check. And here, jalr does use rs1. Okay, I totally forgot about that. Well, wait, hold on. That's for rs1 though. What did he say it was missing for? Wait, what? No. It should cover in this. It should cover in this. I don't know why Cloud was saying that. That should cover in that one. Yeah, that should be covered. I don't think I need to fix anything with that. Okay, let's recheck. Yeah. Jalr should be covered in the return true. Anyways, I need to change anything. Is it all good? What do you mean? Am I missing something here? Let me see. Okay, think about fmin-max instructions like fmin, fmax use 2 floating point source registers. Is fmin-max covered in these rs2? Let me check. Yeah, they do use 2 floating point registers. Okay. Okay, I just missed their case. I didn't see that. That's my bad. Yeah, okay, so F and max. Yeah, I just totally forgot about their case. What are the things? Also uses floating point register. This FP convent need to be in there. Let me see. No, because no, it does not need to be in there. That's converting from floating point to int, so we don't need that, I'm pretty sure. Let me just take a look though. What's classified under convent? Let me see again. FCVTWS, let me check that. So it's using floating point register. Yeah, it's an integer register, so that does not need to be. It doesn't need to be there. So it's not really a float source. I feel like Cloud's just like fucking with me, bro. Cloud's messing with my head right now. One more. Fcomp uses 2 floating point source registers, but you have it in uses rs2. Well, yeah, it should be there. Fcomp instruction should be. Dude, Cloud is fucking with me, bro. Okay, everything should be good. Now. I added the FN max. Alright. Final check, bro. Final check. It should be good. Okay, cars rs1 is float. And as for the register, or no, use this floating point register. Where rs1 is a float. Yeah, they read. I'm pretty sure they read integers. No, they don't. No, they read floating point. That's right. Why is it not? Let me see. I guess you're. Wait. No, but they loaded into an integer register. I seriously think Claude's just messing with me at this point, bro. They should be right. I think I can just move on. Alright, we need to write the forwarding engine now. Forwarding engine. Okay. I guess, okay, I think he's getting confused because this is... Well, no, it's... I mean, it's technically right. I think I'll just rename it though. I'll call it isFloat instead. So I guess Cloud doesn't get confused in the future. Okay, we can write. Okay, so what exactly do we need? Let me think for a second. What do we need? Okay, so if we have like a hazard from execute, okay, so we need that destination register. We would need from the previous stage of that value and we're forwarding that from the xmem register. Okay. Okay. I'll write first. So first we need to make sure that it's okay. Let's write it. So if we're writing to, it's called writes to register, right? Right, yeah, it's right there. Writes to register. Okay, so in the case that we're writing to register, we need to get the value forwarded. And for writing to register, we need to check the type. So we're checking from the memreg, xmemreg, because that's where we're taking it from, the xmem. And it'll be, well, yeah, it'll be .inst.type. I think we can write it like that. And I believe that's the only parameter, I believe. That is the only parameter, so that's good. So if in the case of that, so that's the first condition that needs to be done. So if that's the case, we should cover each case perfectly. So we can have a case of writing to a floating point register, any integer registers that we use here. Let's cover the floating point one first. So let's just say if it's true. So if it's float, let's just call it that. And we'd be taking from the function isFloat. Yeah. I'm kind of slow right now. I'm kind of trying to think about it. Okay, yeah, we just need to pass in the parameter. No, we already have that instantiated, so just be the same as how we did there. So x reg.inst.type, and we should call that what's going on? It is float, right? So what's the problem? Oh, okay, I guess this is cladding. let's call this x is float, because we're taking it from the execute phase, that part, so we can call it that essentially. What else? Okay, so that's gonna call that as true. If that's the case, if it is a floating point one, then we can check. So if our x is float, if it is a floating point register value that we're using, or okay, what cases would we use integer register, the destination register? I believe every case except for x0. So it's the d. Well, we need the execute one, so let's call it like this. Okay, so if this is not equal to 0, we can use them, and let's go. It's another if statement. It's gonna be quite a nasty nested if statement, but we'll just write it for now. If I need to change anything, if there's a better way, then I will, but I just want to get the logic down first. Let's see. So I guess now we need to invoke our different helper functions up here to use the value, the proper value. I think I'm gonna call it, I'm gonna just separate the values. So x uses, it'll make it easier for me to reuse. So if x uses rs1, and we'll call that function. So if we're using the rs1 function, audio is good, right? All right. Just don't want to make sure that the audio is fine. Okay, so we're using rs1, and yeah, it's just gonna be this. I should start speeding it up a bit since I kind of understand, and we'll do the same for the rest of these as well. So we'll call them like bool x uses rs2, and take the type there. And what are the helper functions? Oh, use rs3. Okay. X uses rs3. And that will invoke the rs3 function and take the type. So now it should be easier to call upon them. So in what case would we need to write it to? I guess these need to be equal, right? that only happens if this is equal to this. So, So if x uses rs1, that rs1 value is equal to the x mem inst.rd. So if these two values are the same, that invokes that means that it's an x hazard, meaning that we need to forward from the result. So let's do that. And then out here we can distinguish between wait a second, would that work though? Let me take a look at the struct again. I think it's just rs1, right? Yeah, no, that would work. That'd be fine. It wouldn't work if it was split though. So that's good that we didn't split it up earlier. Okay, that should be fine. Alright, so yeah. If it's a float and if it's the destination register for int is not equal to 0, then it invokes this. If it uses rs1 and make sure that the rs1 is equal to the xmem register, then it will be a x hazard. So then it will invoke this next part, which will be, we should distinguish now here between the floating point and integer. So we can take our x is float value. Well, I guess just that. Or it's only one line, so I guess we can write it on one line. But we're going to be taking it from the IDX register. And in the struct it was rs1f value. Yeah, rs1f value. Okay, no, that's good. Well, wait. This. So we're rewriting that value to be from xmem instead. So changing that value. What value are we exactly taking? I guess it would be the ALU result. Well, in this case, it would be the ALU F result. And then else. If this is an integer, it will be I can't talk right now. The rs1 value would be equal to this value here, but ALU result. Okay, just to make sure I'm getting things right here, let's just check. Let's just check that I have things going right. Then I can write the rest. So far, I will write the rest if this is good. If there's a problem, don't code, just you really gotta get it into Claude's head, or else Claude will start writing code for you. A few issues. You're modifying. Okay, I literally said don't give code. Okay, but I guess it's fine. It's one line. Okay. You're modifying ID x reg directly. You should be modifying local variables rs1, rs2. Instead, it's a current pipeline register, and other stages might read. Modifying a mid-cycle breaks the pipeline model. Declare local forwarded values at the top and use those in the switch. Okay, so we're modifying it directly. Okay, does he mean like... Does he mean like setting something like this? Perhaps something like this, I believe. Let me just check. Do you mean something? I think that's what he's saying, but okay, alright, that makes sense, but I want to know what are the implications. Of doing that for okay. Oh, so I need to refactor that. I need to refactor that again. Ah, damn. Okay. Then what's the point of doing that? Let me think. Let me think. Since we're going reverse decoration, right? So if we these values, so these values here. Okay, I guess I see why it's a problem. These values are being passed down to the next one, but we're overriding them. I'm just gonna. I need like a bigger picture on this. Hold up. Forwarding, value read from register file 2 cycles ago. Detected. Okay. 1 second, I need to charge my headphones. I guess it's fine. I won't need them. Right. Yeah, I mean, I guess it's fine. Yeah, we can refactor that, I guess. Yeah, I see where he's going with this. It will break the pipeline model. Because let's say if there's not an X hazard, then we're changing the value. Yeah, I guess, okay. It's taking me a bit to wrap my head around this part. Sorry about that, guys. Variables. Yeah, I get that we're modifying directly. So it uses. It's bad because xreg is shared state. Yeah, we're sharing it between all the other stages of the pipeline. So, okay. I think I understand it better now. Like, may override if the hazard is detected. Alright, with this last query, if you can explain me this one part. I'm just confused on this one part. Wait. Okay, but if we don't touch ID X. is more about design principle than correctness. IDX red represents the captured state of what was decoded. It's a historical record of what the decode stage saw. There's the line what was decoded and what we're computing with. If you're new to debug or inspect the pipeline, say a modified ID _x reg, the RS1 values no longer actively reflects what the decode stage actually reads from the register file. Okay. Faithful record of decode stage output. Yeah, I mean, he said it would change it, like it would make it actually not work. But now he's saying it's fine. Okay, let me just do a couple more queries. I need to make sure that everything's fine. So how do we know that the rest of the pipeline is using correct and updated values if we are changing the local variables here in the next stage? Oh, okay, I guess you're right there. Okay, I need to ask one more thing about this part. Okay, yeah, I mean, I just needed to actually ask Claude why I need to change the format, but I guess it's fine to keep the format. I just need to claw him a bit, just to make sure he's not giving me a bad thing. So yeah, we can keep it, I guess. Damn, he's kind of condescending though. If that feels simpler to you. Okay, I'm just gonna do it. I'm just gonna keep it. It works right now, and it'll work. It'll work for everything. Everything will be fine. I don't see a point where I have to really change it. Even debugging, it'll be easy to do it. So yeah, I'm not gonna change it. Alright, let's just continue on with the regular values. And if I ever do change it, it'll just be one little thing to change, so. Okay, yeah, I think that's fine. Let's do the rest of them. So we have x uses _2, and same case. but it's just gonna be this instead. And I think we just take this, same exact thing. We're just going to change these values here. So we have the rs2 f value and rs2 value. So that works. Same exact case for rs3. Just changing up this part right here. Okay, rs3 and well, this one wouldn't need anything since there's no such thing as an rs3 regular value, so it'd just be like that. I mean, that covers the X hazard, right? Now we can do mem hazard. We'll do mem hazard and then end the stream. Tomorrow, I think if that's the end of the forwarding engine, we can just do the stalling engine tomorrow. Yeah. Stalling engine's the next thing we have to do. We can tackle that tomorrow. For the mem hazard, let's see how it's implemented. So for the mem hazard, we have a register. Okay, so if the destination register, well, my glasses are dirty. Okay, so if the destination register from mem write back is equal to the IDX register, rs1 or rs2 value, we forward from mem write back. So okay, it's just a step before. So it's essentially the same implementation, it's just a step before. So yeah, it's just writes to, just like before, if writes to register, and that value will be, I'm gonna save my work here real quick. Okay, X. Well, in this case, it would be mem write back. Inst dot type. Yes, and it takes that value. Okay, so if that's the case, it's same thing, right? Bool access float. Bool uses rs1. Grabbing the exact same values here and putting it in here now. Then we should cover the value. So if X is, if it's a float value, if it's using a floating point register, and mem write back register that inst.rd is not equal to 0, so we can operate on it. Then we move forward. Let me read this again. Okay. Okay. Well, I guess we can just copy this pretty much over. But it would just change in the fact that this would be mem right back now. So all we need to change is mem dot right back for each value in here. For this part at least. So it'd be the mem right back register. Then here, is it IDX? It is IDX, and then also mem right back. It'd be mem right back here too. So we're checking mem right back. So here as well. So we need to check these values. So we're checking for the mem right back stage, ALU.F result. I think that's fine. Oh yeah, here as well. I'm not actually sure. Let me check. Okay, yeah, I just wrote it wrong. That's my bad. Okay, that's fine. And we can just, oh wait, shit. It has to be mem for each one. That's my bad. Wherever mem is floats, I need to just change it to this. So just a couple places. It shouldn't be too long. Let's float. And also these two need to change as well. It'll be mem and mem. So let's change each one here. Okay, I think it's all good now. I totally forgot about that. Good thing Claude corrected me there. Oh shoot, he's totally right, dude. Bubble check. Oh my god, dude. I almost forgot about that. That's probably one of my problems as like a dev. Like I kind of forget things sometimes, but I guess that's normal for everyone. We need to check the so it'd be like the bubble for mem right back. So if it's not what was it again? Bubble? Just bubble, right? Okay, so if it's not a bubble. So if it's not a bubble and that. Okay, and then also up here, I guess, too, right? And Yeah, this would be for maximum. Yeah, I totally forgot about that. I totally forgot about that, dude. Oh my god. What else? Is mem read, not alien result. Right back is a load. Oh. Okay, I guess the load instructions as well. Okay. So I guess we can kind of instantiate that here itself. Or we don't really need to, I guess. We can just call it here. Well, it's kind of complicated. We'll just make two separate variables here, so I don't have to make this more complicated. So let's take an unsigned 32-bit unsigned and let's just call it like mem int, and that can be, we can make it like a ternary operator. So if the type is a load, we have to do this. Take in the mem read, else take in int, the int value, the normal ALU result. Okay, so let's do that. So it's a type. So if our, I messed up. So if our instruction type is a load, we can, so just like over here, so it would be, start, it's called mem read, right? Mem read and mem fr read, so we have to distinguish that properly. Why did they go there? Okay, so mem read, else, I guess just take this value. It's gonna be this. We're gonna be taking this value. So yeah. Okay. Yeah, and then we can do the same for float. So float mem float equals to mem underscore right back. Floating point load also does that, so we're gonna have to, yeah, we're gonna have to do this still. And in each one, we're changing this value to mem float. Well, I guess we don't need the mem dot write back since we already did that, so just mem float itself, since that encompasses this mem dot write back. So that should be good. Dude, oh my god. I just had like a thought. I was just checking back on the stream to see how bad my audio was in the beginning. I'm gonna check that next time, dude, and make sure. I was thinking of checking the audio, but dude, I totally like said no, nothing's gonna be wrong, and then it ends up being wrong. And yeah, just always make sure to check. That's a little life lesson there. Even if you think that nothing's gonna happen, just you gotta check, bro. If you have a doubt. Int. Same thing here. And int. Dude. Yeah, I meant. And I forgot to put this. So. I think it's all good now. Okay. Yeah. I will check these, you know? Let's check these. Did I not? Okay, there we go. Yeah, did I forget? I forgot these two. Why am I forgetting so many stuff, bro? Okay. Alright, finally it should be fine. Wait, but... Oh. Oh. Okay. Maybe I still have a bit of holes in my thinking. Not gonna lie. Okay. Let's check the whole thing. Check if everything's good. Since we're doing a reverse declaration. I understand. Since, yeah, I could overwrite. Yeah, I totally forgot about that. Since we're, anyways, declaring this in reverse, we need that to go the same path for that thing. So mem hazard should be first. That should finally be good, and then let's check everything. I hope there's not a huge amount of errors, or else I'm gonna have to debug a lot. Let's see what's going on. Largely complete. Why can't it be fully complete? Let's see what's going on. Forwarding priority issue. Mem hazard once before X hazard in your code. This means X hazard. No, I changed it though. Didn't you mention that mem was first? Oh no, he's saying to check. So this shouldn't be, let's go back in the code. This doesn't need to be first, but, but there does need to be some sort of check to make sure that it doesn't get to this part, just to make sure. Since X comes first in both blocks, use direct assignment. How would I check for that? I guess like a huge if block over it, right? Hmm. I'm not exactly sure, to be honest, for this part. Right. I forgot to declare this earlier. Wait, how do I check for that though? Yeah, I'm writing the stalling engine after, but hmm. I don't know about that, to be honest. Oh, you were wrong about it. Okay, so I had it right initially. He was just wrong about it, so let me change it back. Looks like we don't need to have that changed. Looks like it was right. Okay. Yes, the load use hazard, that will be tomorrow for the stalling engine. So I will do that tomorrow. Today was a pretty successful stream though. Let me just commit before I head out. Forwarding engine complete. And let's push it. Okay, looks like it's all good. Looks like it's pushed correctly, and yeah. I think we are officially done with today's stream. That was actually a pretty good stream, we got a lot done. So yeah, I'll see you guys tomorrow for the stalling engine.